Okay, so today I want to talk about how to graph quadratic functions, and I want to look at everything that goes with quadratic functions. Like, we want to look at all the characteristics, and we can pull all those out. But before we do that, we have to look at what A equals, what B equals, and what C equals. Now, A is associated with the number that is going to be in front of x squared every time. So if we don't have an x squared, then we don't have a quadratic function, right? And so if you look at the number, there isn't one. So we know that there's going to be a 1 there. So that means that A is 1. B is the number that's in front of x. If we don't have an x, then it would be 0. So since B over here is -6, we're going to put -6. And then finally, C is going to be 5, which is the number that's last, okay, and doesn't have any variable with it. Now, to be able to graph quadratic functions, we have to find the vertex, right? And the vertex is that turning point that we've been discussing. So the turning point is found by using the equation x equals -b over 2 times a. And this is the equation that you're going to be able to use every time. We're going to pull b and we're going to pull a from over here, and we're just going to plug them in. So x is equal to -6 over 2 times 1. And if you look and put that in a calculator, you're going to get 3. What that tells me is that the x coordinate of my entire graph for my vertex is 3. Now, what I can do with that 3 is I can plug it back in to find my y value. So if we look at our original function, y equals x squared minus 6x plus 5, I can take my 3 and plug it in where I see x. So I have 3 squared minus 6 times 3 plus 5, which means y is going to equal -4. So that means I have a vertex of 3, -4, which is where my center point is basically on my graph. So what I need to do now is I need to create a table of values, and that will allow me to graph this entire thing. See, I got a graph around 3, -4. So I need to go below that, and I need to go above that so that I can create symmetry. See, I need to pick these whole numbers that are around my x value. And then I got to take these numbers and plug them in to my function so that I can get the entire graph ready to go. So if you look, I'll do that with 1. So y equals 1 squared minus 6 times 1 plus 5. 1 squared minus 6 times 1 plus 5 is going to be equal to 0. So that tells me that this is going to be 0. Let me jump down and just try 5. So if I plug 5 in, y equals 5 squared minus 6 times 5 plus 5, and then that is going to equal 0 as well. Since it's 0, you should notice something. You should notice that there is symmetry. So you have a 0 on the top and you have 0 on the bottom. If you take 2 and you plug it in, you're going to get -3 out, which means that when you plug 4 in, you better get -3 out as well, because you want to see symmetry. And so when you graph this function, it's going to create symmetry. All right, let's go ahead and graph the function. So when we graph it, we want to set it up with our x and y coordinates. We can go by ones because it's not very large. We have our table, which is 1, 0, 2, -3, 3, -4, 4, -3, and 5, 0. Now we can graph all those, right? So we can go ahead and plot them. So let's start with 1, 0. 1, 0. We have 2, -3, 3, -4, 4, -3, and 5, 0. And notice you have this symmetrical graph because we've centered everything around the vertex. Now we have to identify some parts of this graph, okay? So what we have is we have a vertex, which we should know already is 3, -4, and that came from our table. Our vertex is going to be a min value. You should know this because it's the smallest point on the graph. It's the minimum. If it was opening down the graph, then it would be a max. Another way to know that is if you look at A. If we look back, A was 1. So since A was 1, we know A is bigger than 0, right? Because 1 is bigger than 0. And since A is bigger than 0, that tells us that the graph is going to open up and not down. Now, we also need to discuss some different things like the axis of symmetry, which I just refer to as AOS. You know that the symmetry around here is on the vertex if you watched the previous video. You take a look and you know that there's a line that's going to go down through here that we just don't see. And I can fold that over now on top of itself. Well, really all that is that's just your x value of your vertex. And the equation of that is always x equals whatever your x value is. Now you got to put x equals because we're talking about the equation itself, that line that's coming down through there. And that's how you identify the equation of a line that's vertical. It's x equals 3. So that's always going to be that way. So if my vertex was 2 something, then my axis of symmetry would be x equals 2. All right, so we can continue. Let's take a look at the domain. Domain, you know, is the x values. It's everything I can plug in. And every time I have a quadratic function, it's always going to be all real. I can plug any number I want to into this function, anything, and it doesn't matter what I get back. Range. I can plug anything in, but when I think about getting stuff back, I got to think about my y values here. Okay? Now, I can't plug anything in and get anything back. If you look, my graph doesn't go below this little squiggly line. So that tells me that it can only go down to -4. But if you look, it can go, because of these arrows, as far up as it wants to. So that means y is going to be greater than or equal to my vertex value down here, which is going to be -4, because that's my y value of my vertex. So let's just recap. The axis of symmetry is the x. The range is the y. And so we have to think about that whenever we're doing any quadratic function. You can identify domain and range that way. Domain is always going to be all real. Range is going to be, well, depends on what is happening. Since this is going up, it's going to be greater than. If it was going down, it would be less than. But since it's going up, we're going to say it's greater than or equal to -4. Okay? Continuing. If we think about zeros, which is where it crosses our graph, it's also our solution. Okay? They're known as roots or solutions or zeros. Zeros is where it's going to cross your x-axis. Well, we have those right there, don't we? Those coordinates are 1, 0, and 5, 0. And basically, it's where y is 0. And we know that from our table. This thing has 2 solutions. Okay? Now, sometimes there's quadratic functions that don't have any real solutions. And those would be quadratic functions that never cross the x-axis. Like, for example, if I draw one over here, this would never cross the x-axis. See, it just starts below it and continues to go down. So this would be a function that would have no real zeros and no real solutions. Okay, so the solution is known as the zero. It's also known as a root. Okay, but this is how we're throwing it all together. So everything that we've already talked about is right here. We have the vertex, the axis of symmetry, the zeros, the domain and range, and how to graph these things. You need to think about when you're graphing, always creating something, creating a table that is around our value, our vertex value.